Hello, W9. Right, okay, elastic energy. Here you go. Quick starter, and then we'll progress. There you go. There's the starter. Pause your video, do it. Okay. Here we go. So this relies on a bit of knowledge for about Hooke's law. If you're not sure about Hooke's law, go and look it up on free science videos. You know, weight's the force of gravity. We calculate work done is force distance. Hooke's law is F equals KE. We know how to measure energy, number 4. And the spring constant is something that tells you how stiff a spring is or an elastic material. Okay, these are the 3 things that you should be able to do by now, or if you don't, go and find out. But we're going to calculate energies. Okay, simple lesson. Okay, a spring constant tells you how stiff a spring is. Very simple experiment. We hang up a spring, we add weights. Okay, and we can see that little picture there. And then we just measure how much it stretches by. And if we plot that data of weight on the x-axis and extension, we end up with a straight line relationship, which means the spring is obeying Hooke's law. Okay. From that graph, if we so wish, we could actually work out the spring constant. It's just the how much force is applied divided by how much it's stretched by. And in this case, it's 200 newtons per meter. That means it takes 200 newtons to stretch this spring 1 meter in length. Okay. Notice I've used 0.08, not 8 centimeters, because we do things in meters. Okay. So when we stretch a spring, we're doing work. Okay. You use energy to make it stretch. Chemical energy from your muscles transferred into elastic energy within the spring. It doesn't disappear when you let go. The spring returns to its natural size and gives back out that energy, usually as heat. Okay, this is why when you bounce balls and things like that, eventually they come to a stop because all the squishing and squashing, that spring energy gets turned into heat. Okay, we can calculate it. If you look at the bottom of the screen there, there's a little formula. Elastic energy is a half KE squared. It's very simply a case of, to work out the elastic energy, we just plug the numbers in. Okay, KE squared. And this works if we compress a spring too. If we have a spring that's sort of stretched out and we squash it, okay, then we can still use that formula where E is the extension. And so in word formula is there. And note, EPE, elastic potential energy, is the energy stored in a body due to a load, that's a weight or a force acting on it, causing a deformation. That means a change in shape. Okay, so these are the key definitions. Okay, so how much elastic energy is stored in this spring? Okay, we know it's spring constant. It tells us on the screen there that it's 200 newtons, and that should say per meter. Okay, that's a typo there. Apologies for that. Okay, what we can do is we can choose some values. So I know that when the weight is 1.2 newtons, the extension is 6, and then we just plug the numbers in. We write our formula down, put our numbers in. Notice that's 200 and 0.06 squared, and then we calculate our answer. And our answer will be in joules. We could use Newton meters, but joules is better. Okay, simple, simple, simple. Right, now's yours task. This sheet is found in the resources, so it'll fill in the gaps and some calculations. And I'll be back later with the answers to those calculations. Have a go. Okay, true or false? Write down numbers 1 to 5. Good, and we begin. True or false? Work is different to energy. All materials can be a store of elastic potential. Is that true or false? Is this true or false? The spring constant can be measured in newtons per centimetre. Elastic energy is the area under a force extension graph. Springs with a large spring constant are easier to stretch. Okay, true or false, true or false. Pause it. And we're back. Here we go. That's false. Work and energy are the same. All materials that can be squashed can store elastic potential energy. Okay, even things that aren't particularly elastic, if they are deformed, they will, or changed of shape, they will store potential. The spring constant can be measured in newtons per centimetre. We tend to use newtons per metre. Just be aware of that. Elastic energy can be found by the area under the graph. Okay? If you look at the formula, it's a half k e squared. We can actually get to that by measuring the area under the graph, which is a triangle. Okay, so we can actually get to that. And springs with a larger spring constant are easier to stretch. That's false. It's got a large spring constant. It's really, really hard to stretch. Okay, so have a go at the calculations. Those answers will appear in Teams and I will notify you. In the meantime, have a look at free science lessons on YouTube and actually look up elastic energy. It's only a 5-minute video. The guy's really good and covers all the bases. Okay, thank you. Bye-bye now.